Welcome back to Oliver's Stories. Tonight, I want to take you somewhere you have never been. Not to a city or a country, but to a shoreline that no longer exists. A narrow strip of land where the Red Sea once parted not for miracles, but for ice. 70,000 years ago, your ancestors stood on that shore. Behind them was everything they had ever known. Africa, the birthplace of their kind. Ahead was nothing. No maps, no roads, no promise of safety, just dust and sea, and the vast, terrifying unknown. And yet they walked forward. Tonight, we are going to follow them. Across deserts that swallowed armies, across oceans that sank ships, across frozen wastelands where the sun barely rose. We are going to learn how a handful of people, maybe a few thousand in total, became the most widely distributed species on Earth. This is not a story of kings or empires. It is a story of ordinary people who did something extraordinary. They left, and they never stopped leaving. Picture this. You are standing on the windswept shores of the Red Sea 70,000 years ago. The water level is dramatically lower than today, revealing a narrow corridor of exposed land and shallow crossings. Behind you stretches the vast African continent, where your species, Homo sapiens, has lived for over 200,000 years. Ahead lies the unknown, Arabia, Asia, and eventually every corner of our planet. What drove your ancestors to leave everything they knew? What incredible challenges did they face, crossing treacherous waters, frozen landscapes, and endless deserts? How did a small group of perhaps just a few thousand people manage to populate entire continents? From the scorching outback of Australia to the tundra of Siberia, this is the story of humanity's most extraordinary adventure, a tale of courage, innovation, and survival that spans 70,000 years and covers every habitable landmass on Earth. A journey that took our species from the cradle of East Africa to the towering peaks of the Stalker, Himalayas, across vast Pacific oceans to remote islands, and ultimately to the icy shores of the Americas. Today, we will follow in the footsteps of these ancient pioneers, uncovering the latest scientific discoveries that reveal how climate, genetics, and human ingenuity combined to make us the most widely distributed species on the planet. From the bustling markets of ancient Arabia to the pristine beaches of Polynesia, this is the epic story of how we conquered the world. The story begins in the heart of East Africa, where volcanic forces have shaped both the landscape and human destiny. But these early humans were not alone. By 100,000 years ago, humans had dispersed and diversified into at least 4 species. Our own species, Homo sapiens, lived in Africa and the Middle East. The Homo neanderthalensis lived in Europe. Homo floresiensis lived in southern Asia. Competition was fierce, and survival demanded innovation. Evidence from South African caves reveals a revolutionary transformation occurring around 80,000 years ago. In a cave at Pinnacle Point in South Africa, a team led by Arizona State University, paleoanthropologist Curtis Morahan, found evidence that humans 164,000 years ago were eating shellfish, making complex tools, and using red ochre pigment. All modern human behaviors, these were not just minor advances. These advances represented cognitive leaps that would prove crucial for long-distance migration. The archaeological record reveals that something extraordinary happened around 70,000 years ago. According to Blombos archaeologist Henshelwood, about 80,000 years ago, modern humans entered a dynamic period of innovation. The evidence comes from South African cave sites such as Blombos, Klassies River, Diep Kloof, and Sibudu. Suddenly, humans were creating sophisticated bone tools, intricate jewelry, and complex weapons. They developed new hunting strategies, began practicing symbolic behavior, and most importantly, started thinking about the world beyond their immediate environment. This cognitive revolution was not just about making better tools, It was about developing the mental frameworks necessary for exploration. These early humans began creating mental maps of vast territories, understanding seasonal patterns across different regions, and developing the social cooperation needed for long-distance journeys. They were learning to think like explorers. But why leave Africa at all? The answer lies written in ancient climates. Cold, arid conditions during the first half of the last ice age, from 110,000 to 60,000 years ago, were punctuated every 20,000 years by warm summers in the northern hemisphere. These climate shifts, triggered by the wobble of Earth's axis, created green corridors between Africa and Eurasia that set the stage for migratory waves of Homo sapiens. During dry periods, populations concentrated around shrinking water sources, creating pressure and competition. When the rains returned and green corridors opened, these same populations faced a choice: compete for resources in familiar but crowded territories, or venture into the unknown. The most adventurous chose exploration. The oldest known Homo sapiens fossils outside of Africa come from caves in Israel. Mislia, about 180,000 years old. Skul, about 90,000 years old. Kufsa, about 120,000 years old. These represent humanity's first tentative steps beyond Africa, but they were not permanent settlements. Archaeological evidence suggests these early pioneers established temporary footholds in the Levant, possibly following animal migrations or seasonal resource availability. Remarkably, these early attempts often ended in retreat or extinction. Intriguingly, 70,000-year-old Neanderthal remains have been found in the same region. The modern humans, it would appear, arrived first, only to move on, die off because of disease or natural catastrophe, or possibly get wiped out. Competition with established populations like Neanderthals was real and often deadly. But each failed attempt taught valuable lessons. These early migrants developed crucial skills: navigation by stars, reading weather patterns, understanding which plants were edible in new environments, and most importantly, how to cooperate in small groups under extreme stress. They learned that successful migration required not just physical courage, but careful planning, resource management, and adaptability. The genetic evidence tells us that modern humans outside Africa descended from a relatively small founding population, perhaps just a few thousand individuals. This genetic bottleneck suggests that the successful migration out of Africa was a near miss for our species. Had climate conditions been slightly different, or had these pioneers made different choices, the story of human global expansion might never have begun. The stage was set for humanity's greatest adventure. The innovators were ready, the climate window was opening, and the accumulated knowledge of previous attempts provided the roadmap. The next phase would take our species across the threshold, from African inhabitants to global citizens. Around 70,000 years ago, a confluence of factors created the perfect conditions for humanity's successful exodus from Africa. A study found that humans traveled out of Africa in 4 waves across the Arabian Peninsula and the Levant region of the eastern Mediterranean. These waves occurred from 106,000 to 94,000 years ago, 89,000 to 73,000 years ago, 59,000 to 47,000 years ago, and 45,000 to 29,000 years ago. Earth's orbital mechanics had aligned to create what scientists call green corridors, lush pathways of vegetation that stretched from the Horn of Africa across the Arabian Peninsula. Precession is the wobble of Earth's axis of rotation caused by the gravitational pull of the Sun and Moon. It causes changes in the timing of the seasons and seasonal contrasts between the northern and southern hemispheres, including shifts from periods of drier, colder climates to warmer, wetter climates in tropical and subtropical regions. Unlike previous attempts that focused on the northern Levantine corridor, This successful migration followed what scientists call the southern route. Practically all of the early waves seem to have gone extinct or retreated. Present-day humans outside Africa descend mainly from a single expansion about 70,000 to 50,000 years ago via the so-called southern route. Picture small bands of 20 to 50 individuals following the Red Sea coast, then crossing the narrow Bab el-Mandeb Strait, perhaps only 12 kilometers wide, during periods of low sea level. Archaeological evidence supports this coastal migration strategy. The discovery of stone tools in the United Arab Emirates in 2011 at the Faya site in Jebel Faya indicated the presence of modern humans at least 125,000 years ago, leading to a resurgence of the long-neglected North African route. This was not a mad dash across unknown territories. These migrants were following a sophisticated strategy, island hopping along fertile coastal areas where fresh water met the sea, where shellfish provided reliable protein, and where storms could be weathered in coastal caves. They had learned from the failures of previous attempts. As these pioneers moved through Arabia, they encountered a landscape dramatically different from today's harsh desert. During this climatic window, much of Arabia was a network of lakes, rivers, and grasslands, a highway of resources stretching toward Asia. Archaeological sites in Oman revealed tool technologies that bridge African and Asian styles, suggesting these migrants were adapting their techniques to new materials and challenges as they traveled. In Oman, a site was discovered by Dr. Jeffrey Rose in 2011, containing more than 100 surface scatters of stone tools belonging to the late Nubian complex, known previously only from archaeological excavations in Sudan. Two optically stimulated luminescence age estimates placed the Arabian-Nubian complex at approximately 106,000 years old. What makes this migration even more remarkable is its scale relative to the founding Het population. By some 50,000 to 70,000 years ago, a subset of the bearers of mitochondrial haplogroup L3 migrated from East Africa into the Near East. This genetic marker, carried by perhaps just a few hundred women, represents the maternal ancestry of every non-African human alive today. Imagine the courage required for these small groups to venture into completely unknown territories. They had no maps, no knowledge of what lay ahead, no guarantee that water sources would be available or that the climate would remain favorable. Every decision could mean the difference between survival and extinction for their entire lineage. As these migrants reached the eastern edges of Arabia, they encountered their first major geographic barrier, the vast expanse of the Indian Ocean. But by this time, they had developed crucial maritime skills. There is evidence that modern humans had reached China around 80,000 years ago, suggesting that some groups successfully navigated water crossings to reach Southeast Asia. The archaeological site of Jewalapuram in India provides compelling evidence of this early arrival. Stone tools found there, dating to around 74,000 years ago, show technological continuity with African traditions, suggesting a direct migration route rather than gradual cultural diffusion. These tools appeared just before the catastrophic eruption of Mount Toba in Sumatra, a volcanic event that may have played a crucial role in human migration patterns. The Toba supereruption, occurring around 74,000 years ago, was one of the largest volcanic events in human history. It spewed ash across the Indian Ocean, creating a volcanic winter that lasted several years. Some scientists argue this catastrophe nearly drove our species to extinction, reducing the global human population to perhaps just a few thousand individuals. But recent evidence suggests that rather than decimating human populations, the Toba eruption may have actually accelerated migration. Groups that had already reached India and Southeast Asia found themselves cut off from return routes to Africa. The volcanic ash made the climate cooler and drier, forcing these populations to continue moving, adapting, and exploring new territories. What is remarkable about this migration is its speed. These humans spread rapidly along the coast of Asia and reached Australia by around 65,000 to 50,000 years ago. In just 10,000 to 20,000 years, humans had traveled from the Red Sea to Australia, a distance of over 15,000 kilometers, across some of the most challenging terrain on Earth. This rapid expansion was not random wandering. It was a directed, purposeful exploration driven by increasingly sophisticated navigation skills, social organization, and technological innovation. These migrants had become experts at reading landscapes, identifying resource-rich areas, and establishing sustainable communities that could serve as launching points for further exploration. The Great Exodus had succeeded where previous attempts had failed. Humanity had broken free from its African birthplace and established permanent footholds across Asia. The template for global expansion was established, and the techniques that would eventually take humans to every corner of the Earth had been perfected. The next phase would test these skills against even greater challenges. As humans spread across Asia, they encountered a continent of staggering diversity. From tropical rainforest to frozen tundra, from towering mountain ranges to vast river deltas, this was not just a single migration, but multiple waves of pioneers adapting to dramatically different environments. Many different human species have lived in Asia over the past 2 million years. The most successful was Homo erectus, which is thought to have migrated from Africa to Southeast Asia around 1.58 million years ago, and lived there for more than 1.5 million years. The newcomers, armed with superior technology and cognitive abilities, now faced the challenge of competing with established populations while adapting to environments their African ancestors had never experienced. Success would require innovations in everything from clothing and shelter to hunting, techniques and social organization. The journey to Southeast Asia required humanity's first major maritime achievements. While these dates have been challenged by other scientists, evidence from sites such as Lida, Aceh in Indonesia, shows that Homo sapiens was present in Southeast Asia by at least 63,000 years ago. Reaching these islands meant crossing significant water barriers even during periods of lower sea level. These early mariners developed sophisticated boat-building techniques, likely using bamboo and other materials that do not preserve well in the archaeological record. They mastered navigation by stars, ocean swells, and bird flight patterns, skills that would later enable even more extraordinary oceanic voyages. The Indonesian archipelago became a laboratory for maritime innovation. Archaeological evidence from sites like Tampaling Cave in Laos reveals the extent of these early achievements. Inside a cave in Laos, scientists have dated a pair of modern human bones to between 68,000 and 86,000 years ago. Although these precocious migrants likely did not contribute much genetically to modern populations, they blazed a trail into Southeast Asia that was followed by later generations. The migration to Australia represents one of humanity's most impressive early feats. The earliest wave of settlement occurred in Melanesia at least 33,000 years ago, and since New Guinea and Australia were then linked by land, these dates are contemporaneous, with Australian dates of settlement extending back some 40,000 years and more. Even with lower sea levels during the Ice Age, reaching Australia required crossing at least 90 kilometers of open ocean, the longest water crossing attempted by any hominin species. This was not accidental island hopping by individuals blown off course, but deliberate exploration by groups carrying enough people and supplies to establish viable populations. The success of these Australian pioneers demonstrates remarkable planning abilities. They brought fire, sophisticated tools, and knowledge of food procurement that allowed them to thrive in an ecosystem unlike anything they had previously encountered. Within a few thousand years, they had adapted to environments ranging from tropical rainforests to arid deserts, developing new hunting techniques for megafauna that had no fear of human predators. While some populations moved southeast toward Australia, others pushed north into territories that would test the limits of human adaptability. Archaeological evidence suggests humans, whether Neanderthal or Cro-Magnon, reached sites in Arctic Russia by 40,000 years ago. This northward expansion required revolutionary innovations in clothing, shelter, and food preservation. These northern pioneers faced winter temperatures averaging -20 to -30 degrees Celsius, with limited fuel and shelter materials. Success demanded sophisticated understanding of animal behavior, seasonal patterns, and resource management. They developed techniques for working mammoth ivory, creating complex tools from bone and antler, and constructing substantial winter shelters that could protect small communities through months of darkness. As modern humans expanded into Europe and Western Asia, they encountered Neanderthal populations that had dominated these regions for hundreds of thousands of years. From the extent of linkage disequilibrium, it was estimated that the last Neanderthal gene flow into the early ancestors of Europeans occurred 47,000 to 65,000 years before present, in conjunction with archaeological and fossil evidence. Interbreeding is thought to have occurred somewhere in Western Eurasia, possibly the Middle East. This was not simply a story of replacement or competition. Recent genetic evidence reveals complex interactions between these populations, including interbreeding, that left lasting marks on human genetics. Studies show a higher Neanderthal admixture in East Asians than in Europeans, suggesting multiple contact episodes and complex population dynamics. The interaction between modern humans and Neanderthals represents one of the most fascinating chapters in human prehistory. Both species possessed sophisticated technologies, social structures, and cognitive abilities. The outcome of their encounters would shape the genetic and cultural landscape of Eurasia for millennia. Central Asia emerged as a crucial hub in human expansion, serving as a crossroads between populations moving toward Europe, those heading east toward China, and others turning south toward India. This vast region of steppes and mountains required specialized adaptations for nomadic life, skills in horse domestication, mobile shelter construction, and long-distance resource management. The genetic evidence suggests that Central Asian populations maintained connections across vast distances, facilitating gene flow and cultural exchange between far-flung communities. These networks would later become the foundation for trade routes like the Silk Road, but their origins lay in these early patterns of human movement and adaptation. Each new environment demanded specific innovations. In the dense forests of Southeast Asia, humans developed techniques for working bamboo and other plant materials. In the Arctic, they mastered the art of ice fishing and learned to preserve meat through freezing. In the deserts of Central Asia, they created sophisticated water storage and navigation systems. These adaptations were not just technological, they were social and cognitive as well. Different environments favored different group sizes, leadership structures, and decision-making processes. The diversity of Asian environments produced a corresponding diversity in human cultures, all stemming from the same founding populations, but shaped by local challenges and opportunities. As populations spread across Asia's vast expanses, they experienced genetic drift and founder effects that created the biological diversity we see in modern Asian populations. Small founding groups carried only a fraction of the total human genetic diversity, and isolation led to the development of distinct regional characteristics. This genetic evidence tells a story of both connection and separation, populations that maintained contact across surprising distances, but also groups that became isolated for thousands of years, developing unique adaptations to their local environments. The pattern established in Asia would be repeated on every continent humans colonized. The conquest of Asia represented humanity's coming of age as a global species. The challenges overcome, from open ocean crossings to Arctic survival, demonstrated that human ingenuity and adaptability could triumph over seemingly impossible obstacles. The techniques developed and refined across Asia's diverse landscapes would soon be tested on an even grander scale, as humans prepared to tackle the ultimate challenge, crossing to the Americas. Europe presented early humans with a unique set of challenges that would forge some of humanity's most distinctive cultural innovations. Cro-Magnon are considered the first anatomically modern humans in Europe. They entered Eurasia by the Zagros Mountains near present-day Iran and eastern Turkey around 50,000 years ago, with one group rapidly settling coastal areas around the Indian Ocean and another migrating north to the steppes of Central Asia. The route into Europe was not direct. These pioneers had to navigate through the complex geography of the Middle East and Anatolia, then push through mountain passes and river valleys into a continent dominated by ice sheets and inhabited by well-established Neanderthal populations. The journey required not just physical endurance, but strategic thinking about when and where to settle. When modern humans arrived in Europe around 45,000 years ago, they encountered Neanderthals who had perfected survival in Ice Age Europe over hundreds of thousands of years. These were not primitive predecessors. Neanderthals possessed sophisticated tools, controlled fire, buried their dead, and had adapted perfectly to European conditions. Modern human remains, dating to 45,000 to 47,000 years ago, have been found in Germany, while finds from 43,000 to 45,000 years ago have been discovered in Italy and Britain, as well as in the European Russian Arctic from 40,000 years ago. The speed of this colonization suggests that modern humans brought significant advantages, perhaps superior projectile weapons, more efficient clothing, or enhanced social cooperation. The relationship between these two human species remains one of archaeology's most compelling mysteries. Evidence suggests periods of coexistence, territorial sharing, and even interbreeding. North African groups share a similar excess of derived alleles with Neanderthals as non-African populations, whereas sub-Saharan African groups are the only modern human populations with no substantial Neanderthal admixture. Europe's northern regions demanded revolutionary technological innovations. Humans colonized the environment west of the Urals, hunting reindeer especially, but were faced with adaptive challenges. Winter temperatures averaged from -20 to -30 degrees Celsius, or -4 to -22 degrees Fahrenheit. With fuel and shelter scarce, these Arctic pioneers developed techniques that would define human cold-weather survival for millennia. Sophisticated clothing, made from multiple animal skins, semi-subterranean housing that maximized heat retention, and complex food preservation, methods that allowed survival through months of limited hunting opportunities. They learned to read ice conditions for fishing, track animals across snow-covered landscapes, and navigate by stars during the long polar nights. European archaeological sites reveal an explosion of cultural innovation that archaeologists call the Upper Paleolithic Revolution. This was not just technological advancement, it was a fundamental shift in how humans expressed their cognitive abilities. The cave paintings at sites like Lascaux and Altamira demonstrate sophisticated artistic traditions that required planning, symbolic thinking, and cultural transmission across generations. These artistic achievements were not mere decoration, they represent the development of complex information storage systems. Cave paintings served as maps of animal migration routes, calendars tracking seasonal changes, and repositories of hunting knowledge that could be passed between generations. European humans were developing the cognitive tools that would enable increasingly complex wooden societies. Europe, during the Ice Age, was a landscape in constant flux. Glaciers advanced and retreated, creating temporary lakes, redirecting rivers, and opening or closing migration corridors. Successful human populations had to maintain mental maps of these changes across vast territories and multiple generations. Archaeological evidence reveals sophisticated seasonal migration patterns. Groups would follow reindeer herds north during summer, then retreat to protected valleys during winter. These movements required coordination between multiple bands, suggesting social networks that spanned hundreds of kilometers. The cooperation necessary for Ice Age survival laid the groundwork for the complex societies that would emerge as the glaciers retreated. The Magdalenian culture, flourishing across Europe around 17,000 to 12,000 years ago, represents the pinnacle of Ice Age technological achievement. These hunters developed highly specialized tools for every aspect of survival. Barbed harpoons for fishing, spear throwers for hunting large game, and sophisticated sewing needles for creating tailored clothing. But perhaps their greatest innovation was social, the development of seasonal aggregation, sites where multiple bands would gather during certain times of year. These gatherings facilitated tool exchange, information sharing, mate selection, and cultural transmission. They represent humanity's first steps toward the complex social institutions that would characterize post-Ice Age civilizations. The genetic evidence from European populations reveals the lasting impact of Ice Age adaptations. Modern Europeans carry DNA signatures from multiple founding populations, early migrants from the Middle East, later arrivals from Central Asia, and even small amounts of Neanderthal ancestry that may have provided advantages in cold climates. These genetic patterns tell stories of population bottlenecks during harsh glacial periods, followed by rapid expansion during warmer interglacials. The alternating cycles of isolation and contact created the genetic diversity that characterizes modern European populations while maintaining enough connectivity to prevent complete divergence. Europe's position as a peninsula of Asia made it a natural launching point for further human expansion. The maritime skills developed along Europe's extensive coastlines would prove crucial for later oceanic voyages. The social innovations required for Ice Age survival provided templates for organizing large-scale expeditions. As the Ice Age ended and glaciers retreated, European populations found themselves with the skills and social organization necessary for rapid expansion into newly available territories. The techniques perfected in Europe's challenging environment would soon be applied to even more ambitious ventures, the colonization of remote islands, and eventually the crossing to the Americas. The European experience demonstrated that humans could not only survive in environments radically different from their African origins, but could thrive and innovate under the harshest conditions. The cultural and technological achievements of Ice Age Europe would influence human development long after the glaciers retreated, providing both the tools and the confidence necessary for humanity's final great migration. The Pacific Ocean covers 1/3 of Earth's surface, a vast expanse that could swallow all the world's continents with room to spare. For ancient peoples, armed only with outrigger canoes and celestial navigation, crossing this enormous oceanic realm represented humanity's greatest navigational achievement. In terms of the scale, risk, and magnitude of the exploration, it's one of humanity's momentous achievements, said Barry Rolette, an anthropologist at the University of Hawaii at Manoa. Pacific settlement began with populations that had already mastered complex maritime challenges. The first human settlers of remote Oceania are associated with the Lapita culture, which first appeared in the Bismarck Archipelago in near Oceania around 3,500 years before present. These were descendants of people who had developed sophisticated sailing technologies through thousands of years of island hopping across Southeast Asia. The Lapita culture represents a technological and social revolution that made Pacific colonization possible. The later Austronesian speakers members of the prehistoric Lapita culture, which produced the well-known pottery called Lapita ware, established themselves in the Bismarck archipelago about 4,000 years ago. They then spread to Fiji, Tonga, and Samoa, which have been regarded as the Polynesian homeland. Lapita innovations went far beyond pottery. They developed sophisticated double-hulled sailing vessels capable of carrying entire communities across the open ocean, complete with livestock, seed crops, and fresh water for journeys lasting weeks. They perfected navigation techniques using star patterns, ocean swells, cloud formations, and bird behavior, creating mental maps of ocean territories larger than most continents. Polynesian culture is defined by the islands found roughly in a triangle formed by Hawaii, Aotearoa, New Zealand, and Easter Island, Rapa Nui. But this vast triangle was settled from a much smaller base, the western Polynesian islands of Samoa, Tonga, and Fiji. The earliest wave of settlement occurred in Melanesia at least 33,000 years ago, and since New Guinea and Australia were then linked by land, these dates are contemporaneous, with Australian dates of settlement extending back some 40,000 years or more. For over 1,000 years, Polynesian culture developed and was refined in these western islands. The direct ancestors of the Polynesians are believed to be the Neolithic Lapita culture. This group emerged in island Melanesia and Micronesia around 1500 BCE, from a convergence of Austronesian migration waves originating from both island Southeast Asia to the west and earlier Austronesian migration to Micronesia to the north. During this period, they perfected the social and technological systems that would enable the colonization of the entire Pacific. They developed sustainable island agriculture, sophisticated aquaculture systems, and most importantly, the social institutions necessary for organizing and provisioning long-distance voyages into the unknown. Around 900 to 1000 CE, something remarkable happened. Polynesian navigators broke out of their western Pacific homeland and began the systematic exploration of the eastern Pacific. Our reconstruction of the branching Polynesian migration sequence reveals a serial founder expansion characterized by directional loss of variance that originated in Samoa and spread, first through the Cook Islands, Rarotonga, then to the Society and Tuamotu Islands in the 11th century, the Western Austral and Hapai Islands, and Tuamotu Archipelago in the 12th century. This was not random exploration, it was a systematic island-hopping expansion that followed optimal wind patterns and seasonal currents. Their arrival in East Polynesia, a culturally and linguistically distinct region spanning from the Cook Islands to Rapa Nui and Hawaii, coincides with a time of prolonged drought in their afore. West Polynesian islands of origin in Tonga and Samoa, which may have helped spur the dangerous excursions eastward. Polynesian navigation represents one of humanity's street's most sophisticated pre-industrial technologies. Without instruments or written records, navigators could guide vessels across thousands of kilometers of open ocean with remarkable accuracy. They read the ocean like a three-dimensional map, interpreting wave patterns that reflected off distant islands, identifying phosphorescent displays that indicated proximity to land, and recognizing subtle changes in watercolor that revealed underwater geography. Star navigation involved memorizing the rising and setting positions of hundreds of stars throughout the year, creating mental charts that covered the entire Pacific. Navigators learned to read cloud formations that indicated land beyond the horizon, cumulus clouds that formed over islands, different cloud colors that reflected off lagoons, and the distinctive greenish tinge of clouds over shallow coral reefs. The distances involved in Polynesian expansion stagger the imagination. The findings chart a Polynesian settlement of the vast Pacific that began in the western Pacific in Samoa with their distinctive double canoes. Polynesians then reached the Cook Islands, Rarotonga, in the 9th century, the Society Islands, Tahiti, by the 11th century, and the Western Austral, Tubuai, and Tuamotu Islands in the 12th century. But these were just the warm-up acts. Each successful colonization required extraordinary planning and execution. Voyaging canoes carried carefully selected populations, enough genetic diversity to establish viable communities, but small enough groups to survive the journey. They brought pigs, dogs, chickens, and essential crops like taro, breadfruit, and coconut, along with the tools and knowledge necessary to establish agriculture on uninhabited islands. Furthermore, unlike the long chronology estimates of 200 BCE in the Marquesas, our settlement dates of 1140 CE on Fatu Hiva in the Marquesas, or 28, 4 generations before 1989, agree with the genealogical oral histories of many Pacific Islanders themselves. Tenzo 5 CE, or 29 generations before 1875, on Fatu Hiva. Polynesian colonization had profound environmental impacts that reveal both the challenges of island settlement and the adaptability of human populations. The migrants caught diverse seafoods with nets, spears, lures, and hooks. The large numbers of native birds and animals on the new islands provided a reliable food supply in the early years as the people established their economies. But many species, including large flightless birds, a land crocodile, and giant iguana lizards, were defenseless against this new human predator and soon became extinct. This pattern repeated across the Pacific, initial abundance followed by rapid adaptation as colonists learned to manage limited island resources. Successful communities developed sophisticated conservation practices, seasonal restrictions on harvesting, and aquaculture systems that could sustain populations indefinitely. The failures of these systems can be seen in the ecological collapse of some islands, while successes created sustainable societies that thrived for centuries. Modern genetic analysis reveals the remarkable precision of Polynesian expansion. Analysis by Kaiser and colleagues in 2008 found that only 21% of the Polynesian autosomal gene pool is of Austro-Melanesian origin, with the remaining 79% being of Austronesian origin. This genetic signature tells the story of rapid movement through Melanesia with limited intermarriage, followed by founder effects, as small populations established themselves on remote islands. The genetic composition of each remote island group is dominated by the contribution of its founders, whose descendants rapidly populated it. This pattern allows scientists to reconstruct the exact sequence of Pacific settlement, revealing how a few thousand pioneers ultimately populated millions of square kilometers of ocean territory. Beyond navigation and settlement, Polynesian cultures developed remarkable artistic and architectural traditions adapted to island environments. From the massive moai statues of Easter Island to the sophisticated irrigation systems of Hawaii, these societies created monuments and technologies that rivaled anything achieved by continental civilizations. The megalithic statue-building cultures of the Marquesas, Tahiti, and Nuku Hiva in the north, Raiatea and Huahine in the south, and Easter Island, Rapa Nui, the easternmost of the Polynesian islands settled approximately 1200 CE, demonstrate shared, cultural traditions that maintained connections across thousands of kilometers of ocean. These achievements represent humanity's mastery of the marine environment and the creation of sustainable island civilizations. The Pacific expansion represents the culmination of human maritime achievement in the pre-industrial world. The technology, social systems, and navigation skills developed by Polynesian peoples would remain unmatched until the development of modern oceanic navigation. Their success in colonizing the Pacific demonstrated that no geographic barrier was too great for human ingenuity and determination. The peoples of the Americas represent humanity's final great migration into uncharted territory. For decades, We thought the first humans to arrive in the Americas came across the Bering Land Bridge 13,000 years ago. New evidence is changing that picture, revealing a story far more complex and remarkable than previously imagined. Conventional estimates have it that humans reached North America at some point between 15,000 and 20,000 years ago, but recent discoveries have pushed back these dates and challenged fundamental assumptions about how this final chapter of human global expansion unfolded. The traditional theory is that these early migrants moved when sea levels were significantly lowered due to Quaternary glaciation, following herds of now extinct Pleistocene megafauna along ice-free corridors that stretched between the Laurentide and Cordilleran ice sheets. New genetic evidence suggests that the ancestors of Native Americans did not simply walk across the Bering Land Bridge. They lived there for thousands of years. Based on archaeological evidence, humans did not survive the last ice age's peak in northeastern Siberia, and yet there is no evidence they had reached Alaska or the rest of the New World either. So where did the ancestors of the Native Americans go for 15,000 years after they split from the rest of their Asian relatives? The answer seems to be that they lived on the Bering Land Bridge itself, the region between Siberia and Alaska that was dry land when sea levels were lower. This was not just a corridor for migration, it was a homeland where distinct populations developed over millennia. Genetic evidence shows there is no direct ancestral link between the people of ancient East Asia and modern Native Americans. A comparison of DNA from 600 modern Native Americans with ancient DNA recovered from a late Stone Age human skeleton from Malta near Lake Baikal in southern Siberia shows that Native Americans diverged genetically from their Asian ancestors around 25,000 years ago. Recent evidence suggests that the first Americans may not have used the traditional land route at all. First, coastal America was open by 16,000 years ago, whereas the ice-free corridor between the Sousans and Tiraspools, two ice sheets, was not a viable route until about 12,500 years ago. Second, the population split so swiftly, almost instantaneously, according to their genetics. This fits more closely with southward migration by boat rather than overland. The Kelp Highway hypothesis suggests that early Americans followed the Pacific coast using rich marine ecosystems as stepping stones south. The kelp forests along the Pacific Rim once flourished far beyond today's patches. Those vast swaths of kelp would have made for easier and safer travel, as the nutrient-dense sea vegetable not only fosters an abundance of edible sea life, but dampens waves in the same way that swimming pool lanes do. The discovery of pre-Clovis sites has revolutionized our understanding of American prehistory. At Monteverde in Chile, thousands of miles south of the Bering Land Bridge crossing, archaeologists unearthed solid evidence of a human settlement dating to 14,800 years ago, well before Clovis. But the most startling discovery came from White Sands National Park in New Mexico, where fossilized footprints revealed human presence between 23,000 and 21,000 years ago, thousands of years before the last glacial maximum. These footprints show humans walking alongside giant ground sloths and mammoths during a time when ice sheets supposedly blocked all routes from Beringia into the Americas. Once humans established themselves in the Americas, they spread with remarkable speed. The Clovis first model says it would have taken anywhere from 700 to 1,000 years for people to reach the southern tip of South America. Waters said it seems highly unlikely that the Clovis people could have flown down there in 200 years. Archaeological evidence suggests humans reached Patagonia by 14,800 years ago, meaning they had crossed two entire continents in perhaps just a few thousand years. This rapid expansion required extraordinary adaptability. Early Americans encountered environments ranging from Arctic tundra to tropical rainforests, from high-altitude plateaus to coastal marshlands. They had to develop new hunting techniques for unfamiliar prey, adapt to different seasonal patterns, and create technologies for resources they had never encountered. The arrival of humans in the Americas coincided with one of the most dramatic extinction events in Earth's recent history. Within a few thousand years of human arrival, North and South America lost over 70% of their large mammal species, including giant ground sloths, saber-toothed cats, mammoths, mastodons, and giant beavers the size of bears. While climate change played a role, the timing strongly suggests that human hunting contributed significantly to these extinctions. Early Americans possessed superior hunting technologies, including spear throwers and sophisticated projectile points, that gave them decisive advantages over prey species that had no previous experience with human predators. The abundance of megafauna may have enabled rapid human population growth, but their extinction forced communities to develop more diverse subsistence strategies. Genetic evidence suggests that the peopling of the Americas involved multiple migration waves, not a single founding event. There were three main genetic lineages. The first gave rise to most Native American populations, while later arrivals contributed to Arctic populations and some groups in South America. These discoveries show that between 21,000 and 16,000 years ago, and then a second one around 15,700 years ago, each wave brought different technologies, cultural traditions, and genetic contributions. Some groups may have followed coastal routes, others used inland corridors, and still others may have crossed the Pacific directly. This diversity of migration routes and timing helps explain the remarkable cultural and linguistic diversity that characterized Native American societies when Europeans arrived. Many questions about the first Americans remain unanswered. Sites like Huitlacoche in Mexico claim evidence of human occupation over 250,000 years ago, though these dates remain highly controversial. Other sites suggest possible trans-Pacific contacts between Polynesian and South American populations, evidenced by shared crops like sweet potatoes and similar cultural practices. The Brazilian sites of Serra de Capivara contain rock art and stone tools that some researchers date to 25,000 to 30,000 years ago. Though these dates are disputed, if confirmed, they would suggest either much earlier migrations than currently accepted, or even independent development of human populations in South America. The Americas became laboratories for human cultural innovation. Native American societies developed sophisticated agricultural systems that domesticated crops unknown elsewhere, including maize, potatoes, tomatoes, and chocolate. They created complex urban civilizations like those of the Maya, Aztec, and Inca that rivaled anything in the Old World. In North America, societies like the Mississippian culture built vast earthwork complexes and established trade networks spanning the continent. Arctic peoples developed technologies for survival in some of Earth's harshest environments. Each region fostered unique adaptations that demonstrated human creativity and resilience. Modern genetic studies reveal the lasting impact of these ancient migrations. Every known living and deceased indigenous individual south of Canada belongs to SNA, Southern Native Americans, Raff said, showing how a relatively small founding population ultimately gave rise to millions of descendants across two continents. The arrival in the Americas marked the completion of humanity's global expansion, the final chapter in a story that began in Africa over 70,000 years earlier. From this point forward, humans inhabited every habitable continent on Earth, having demonstrated an unparalleled ability to adapt, explore, and thrive in environments their ancestors could never have imagined. Chapter 7: Islands at the End of the World. While humans were colonizing the Pacific and Americas, another extraordinary migration was taking place in the Indian Ocean. Madagascar, the world's fourth largest island, lay just 400 kilometers off the African coast. Yet, it remained uninhabited by humans until remarkably recent times. When people finally arrived, they came not from nearby Africa, but from Southeast Asia, a journey of over 6,000 kilometers across the Indian Ocean. Adopt the settlement of Madagascar, around 500 to 1000 CE, represents one of history's most unexpected migrations. Genetic and linguistic evidence reveals that the Malagasy people descend primarily from Aranesian seafarers who had mastered oceanic navigation in Southeast Asia and Polynesia. These remarkable navigators somehow crossed the entire Indian Ocean, bringing with them Asian crops like rice and bananas, along with African crops acquired through contact with mainland populations. This transoceanic achievement demonstrates that ancient maritime capabilities were far more sophisticated than previously believed. The Aranesian navigators who reached Madagascar had already colonized islands across the Pacific, and now proved they could traverse entirely different oceanic systems. Their success required adapting Polynesian navigation techniques to Indian Ocean conditions, different star patterns, seasonal winds, and current systems. The Caribbean islands presented their own unique colonization challenges. Unlike the gradual island hopping possible in the Pacific, reaching the Caribbean required crossing significant stretches of open ocean from South American or Central American launching points. The earliest evidence suggests human arrival around 6,000 to 7,000 years ago, with multiple waves of migration bringing different cultural traditions. The archaic peoples who first reached the Caribbean developed sophisticated maritime adaptations for island life. They created specialized fishing technologies, learned to navigate between islands using natural landmarks and sea conditions, and developed sustainable resource management practices for limited island ecosystems. Their success laid the foundation for later, more complex societies. Around 500 CE, the Arawakan-speaking Tano peoples arrived from South America, bringing advanced agricultural techniques and social organization. They established thriving communities across the Greater Antilles, developing ball courts, elaborate ceremonial centers, and trade networks that connected islands throughout the Caribbean. Their achievements demonstrate how island environments could support sophisticated civilizations when properly managed. Some of humanity's most daring maritime adventures targeted the harsh islands of the North Atlantic. The Faroe Islands, Iceland, and eventually Greenland represented the limits of medieval navigation technology and human endurance. These migrations required not just navigational skill, but the ability to establish sustainable communities in some of Earth's most challenging environments. The Norse expansion into the North Atlantic, beginning around 800 CE, pushed the boundaries of what was possible with medieval technology. Reaching Iceland required crossing over 1,000 kilometers of stormy seas, while Greenland lay another 600 kilometers beyond. The Norse settlers who attempted these journeys faced not just navigational challenges, but the prospect of establishing agriculture and animal husbandry and subarctic conditions. Their success in Iceland demonstrated remarkable adaptability. They developed techniques for preserving food through harsh winters, created sustainable grazing systems for imported livestock, and established trade networks that connected their isolated communities with continental Europe. The Icelandic settlement became self-sustaining and culturally innovative, producing literature and legal systems that influenced European development. The North settlement of Greenland around 1000 CE represents perhaps the most marginal, successful colonization in human history. Greenland's environment was so harsh that only careful resource management and innovative adaptations allowed human survival. The Norse established two settlements, the Western Settlement and Eastern Settlement, that persisted for nearly 500 years. These Greenlandic communities developed highly specialized survival strategies. They combined limited agriculture with hunting of seals, walruses, and other marine mammals. They traded walrus ivory and other Arctic products with Europe in exchange for essential goods, like iron and grain. Their success required maintaining connections across thousands of kilometers of dangerous ocean while adapting to one of Earth's most unforgiving environments. The eventual abandonment of the Greenland settlements around 1400 CE illustrates the precarious nature of human habitation and environmental extremes. Climate cooling during the Little Ice Age, combined with changing trade patterns and resource depletion, made these communities unsustainable. Their rise and fall demonstrates both the possibilities and limits of human adaptability. Even after the main Polynesian expansion, isolated Pacific islands continued to challenge human ingenuity. Islands like Henderson Island and Pitcairn Island were settled and then abandoned, showing how difficult it was to maintain viable populations on the most remote Pacific atolls. These attempts reveal both the extraordinary navigational achievements of Polynesian peoples and the harsh realities of island survival, the settlement and abandonment. Patterns of remote Pacific islands provide insights into the minimum requirements for sustainable human communities. Islands needed sufficient fresh water, adequate agricultural potential, and enough marine resources to support populations through environmental fluctuations. When any of these requirements weren't met, even the most skilled maritime peoples couldn't maintain permanent settlements. Easter Island Rapa Nui represents the ultimate test of human island survival. Located over 3,700 kilometers from the nearest populated land, it was settled by Polynesian navigators around 1200 CE. Despite its extreme isolation, the settlers successfully established a population that peaked at several thousand people and created one of the world's most distinctive cultural achievements, the famous Maui statues. The Easter Island story illustrates both human ingenuity and the consequences of environmental overexploitation. The islanders developed sophisticated stonework techniques, created complex social hierarchies, and maintained their culture for centuries. However, deforestation and ecological degradation eventually led to population collapse and cultural transformation, demonstrating the delicate balance required for island sustainability. About island colonization was profoundly influenced by climate patterns and environmental change. Successful settlements often coincided with favorable climatic periods that provided adequate rainfall and stable weather patterns for ocean navigation. Conversely, climate deterioration could make islands uninhabitable or cut off communities from essential trade connections. The medieval warm period, roughly 900–300 CE, facilitated many successful island colonizations, including the Norse expansion into the North Atlantic and the peak of Polynesian migration. When climate conditions deteriorated during the Little Ice Age, many marginal island communities faced severe challenges or complete abandonment. Island isolation created unique conditions for cultural development. Cut off from continental influences, island societies often developed distinctive artistic traditions, social structures, and technological innovations. The Maui of Easter Island, the elaborate stone architecture of Nan Madol and Micronesia, and the sophisticated navigation traditions of Polynesia all emerged from the creative pressures of island life. These isolated communities became natural laboratories for human cultural evolution. Limited resources and geographic constraints forced innovations in everything from agriculture and architecture to social organization and conflict resolution. The diversity of solutions developed by different island societies demonstrates the remarkable flexibility of human cultural adaptation. Island colonization represents humanity's finest achievements in navigation, environmental adaptation, and social organization. These migrations required not just physical courage, but sophisticated planning, technological innovation, and social cooperation. The success of island societies proves that human ingenuity could overcome even the most daunting geographic and environmental challenges, pushing the boundaries of what was considered possible for pre-industrial civilizations. Chapter 8: Climate, Genetics, and Human Destiny. Behind every great human migration lay the invisible hand of climate change. The story of how humans spread across Earth cannot be told without understanding the dramatic environmental transformations that drove our ancestors from familiar territories into unknown lands. These regular climate fluctuations are caused by precession, a type of Milankovitch cycle, or a variation in Earth's orbital movements that affects where and how much solar radiation reaches the atmosphere every 20,000 to 26,000 years. Earth's wobbling axis created periods of dramatic climate change that opened and closed migration corridors, dried up familiar water sources, and transformed entire landscapes. The timing of major human migrations correlates remarkably with these orbital cycles, suggesting that climate change was the primary driver of human dispersal across the globe. Recent climate modeling reveals the precise mechanisms behind these migration pulses. Cold, arid conditions during the first half of the last ice age, 110,000 to 60,000 years ago, were punctuated every 20,000 years by warm summers in the northern hemisphere. These climate shifts, triggered by the wobble of Earth's axis, created green corridors between Africa and Eurasia that set the stage for migratory waves of Homo sapiens. Modern genetics has revolutionized our understanding of human migration by providing a molecular clock that tracks population movements with unprecedented precision. Every human carries in their DNA a record of their ancestors' journeys, genetic markers that reveal when populations split, where they traveled, and how they adapted to new environments. The mitochondrial DNA lineages of modern humans tell story of sequential population, bottlenecks, and founder effects. All non-Africans descend from a small population carrying the L3 mitochondrial HLA group, representing perhaps just a few hundred women who participated in the successful exodus from Carica around 60,000 to 70,000 years ago. This genetic bottleneck explains why human genetic diversity decreases with distance from Africa. Each migration carried only a subset of the total human gene pool. The Y chromosome patterns provide complementary evidence of male lineages, revealing how populations expanded and mixed as they spread across the globe. The timing of these genetic splits matches remarkably well with archaeological evidence and climate data, creating a coherent picture of human dispersal that combines multiple lines of evidence. Human migration wasn't just about movement, it was about rapid adaptation to dramatically different environments. As populations spread from tropical Africa to Arctic Siberia, from sea-level coastlines to high-altitude plateaus, they faced selection pressures that shaped both their genetics and their cultures. Some adaptations were physiological, the development of light skin at high latitudes to maximize vitamin D synthesis, increased lung capacity at high altitudes, and enhanced cold tolerance in Arctic populations. Others were cultural, the development of sophisticated clothing technologies, new hunting techniques for unfamiliar prey, and social innovations for organizing life in challenging environments. The speed of these adaptations is remarkable. Genetic evidence suggests that some human populations develop significant physiological adaptations within just a few thousand years of entering new environments. This rapid evolution demonstrates the intense selection pressures our ancestors faced as they colonized diverse ecological missions. Every major migration involved population bottlenecks that dramatically shaped human genetic diversity. Small founding populations carried only a fraction of their source population's genetic variation, creating the founder effects visible in modern genetic patterns. These bottlenecks weren't just chance events. They were the inevitable result of the challenges involved in long-distance migration, The journey to Australia involved multiple oceanic crossings that could be survived by only the most skilled navigators. The settlement of the Americas required traversing either frozen Arctic landscapes or dangerous oceanic routes. Each successful migration represented the survival of small, highly selected groups carrying specific combinations of skills, knowledge, and genetic adaptations. These bottlenecks created the genetic structure of modern human populations, the relatively low genetic diversity outside Africa, the clinal patterns of genetic variation that follow migration routes, and the distinctive genetic signatures of isolated populations all reflect these ancient demographic events. Some of the most significant human migrations were triggered by dramatic climate catastrophes that forced populations to adapt or perish. The eruption of Mount Toba, around 74,000 years ago, created a volcanic winter that may have reduced global human populations to just a few thousand individuals, rather than destroying our species. This catastrophe may have accelerated human dispersal as survivors spread into new territories. Similarly, the rapid climate changes at the end of the Ice Age forced human populations to adapt quickly to transformed landscapes. As ice sheets retreated and sea levels rose, coastal populations had to relocate, while interior groups faced entirely new environmental conditions. These climate transitions selected for human populations with enhanced behavioral flexibility and technological innovation. Genetic evidence reveals that human populations developed key innovations at remarkably similar times across different continents, suggesting that our species was undergoing rapid cognitive and cultural evolution during the period of global expansion. The appearance of symbolic behavior, sophisticated tool technologies, and complex social organization occurred roughly simultaneously in Africa, Europe, and Asia. This synchronous development suggests that human populations maintained enough connectivity to share innovations even across vast distances. Trade networks, cultural exchange, and occasional long-distance migrations created a global web of information transfer that accelerated human cultural evolution. The relationship between climate and human migration reveals a complex interplay between environmental determinism and human agency. While climate changes clearly triggered major population movements, human responses to these challenges were creative and diverse. Different populations developed remarkably varied solutions to similar environmental problems. The Arctic adaptations of Inuit peoples differed significantly from those of northern Europeans, despite facing similar challenges. The island colonization strategies of Polynesians contrasted sharply with those of Mediterranean peoples. This diversity demonstrates that while climate set the stage for human migration, cultural innovation and human choice determine the specific outcomes. Modern human genetic diversity bears the permanent imprint of these ancient migrations. Population genetics can trace the descendants of specific migration events with remarkable precision, revealing how small groups of ancient pioneers gave rise to entire continental populations. The genetic signatures of human expansion are written in the DNA of every person alive. Today, these genetic patterns also reveal the hidden connections between seemingly distant populations. Native Americans carry genetic markers from Siberian populations. Polynesians share ancestry with Southeast Asians, and Europeans retain DNA from multiple ancient source populations. The story told by genetics is one of connection rather than isolation, a global human family united by shared ancestry despite thousands of years of geographic separation. The period of global human expansion appears to have been a time of accelerated human evolution, both genetic and cultural. The challenges of adapting to diverse environments, the benefits of maintaining longue de vie, contributed to rapid evolutionary change. This period established the patterns of human diversity we see today, the genetic variations between continental populations, the cultural innovations that distinguish different societies, and the technological capabilities that enabled complex civilizations. Understanding these ancient processes provides insights into human adaptability and the factors that shaped our species. Remarkable success, the story revealed by climate science and genetics, is one of extraordinary human resilience and creativity. Our ancestors didn't simply respond passively to environmental changes, they actively explored new opportunities, developed innovative solutions to unprecedented challenges, and created the global human civilization we know today. Chapter 9. The World They Built. By the time European explorers began mapping the New World in the 15th century, they weren't discovering empty wilderness. They were encountering the culmination of thousands of years of human environmental, management, and cultural development. Everywhere humans had settled, they had transformed landscapes, domesticated plants and animals, and created complex societies adapted to local conditions. The scale of human impact was staggering. In the Americas, indigenous peoples had created agricultural systems that fed millions, built cities that rivaled European centers, and managed forests and grasslands across 2 continents. In the Pacific, Polynesian societies had developed sustainable island ecosystems and maintained trade networks spanning thousands of kilometers. On every continent, human migration had led to cultural flowering that demonstrated our species' remarkable adaptability. One of the most significant consequences of human global expansion was the independent development of agriculture in multiple world regions. As populations settled into favorable environments and grew large enough to support specialization, they began the long process of domesticating local plants and animals. This agricultural revolution occurred separately in the Fertile Crescent, China, Mesoamerica, the Andes, Eastern North America, New Guinea, and Sub-Saharan Africa. Each region developed its own distinctive agricultural systems based on locally available species. Middle Eastern peoples domesticated wheat, barley, sheep, and goats. Chinese farmers developed rice cultivation and pig domestication. American populations created complex agricultural systems based on maize, beans, squash, and potatoes. These independent innovations demonstrate how human ingenuity could transform any. The diversity of agricultural systems created different trajectories of social development. Societies with access to high-yield grains and large domesticated animals could support dense populations and complex hierarchies. Island peoples developed sophisticated aquaculture and agroforestry systems. Arctic populations created sustainable hunting and herding practices. Each environment fostered its own unique solutions to the challenges of human survival and prosperity. Human migration and settlement led to the emergence of urban centers on every inhabited continent. From Cataluyuk in Anatolia to Caroline, Peru, from Great Zimbabwe in Africa to Cahokia in North America, human societies, independently, developed the complex social organization necessary for urban life. These cities became centers of innovation, trade, and cultural development that influenced vast surrounding regions. The development of complex societies required solutions to unprecedented challenges. Organizing labor for large-scale construction projects, managing resource distribution in dense populations, resolving conflicts between diverse groups, and maintaining social cohesion across multiple generations. The variety of solutions developed by different societies demonstrates human creativity and social organization. Some societies developed elaborate religious hierarchies and monumental architecture like the Maya pyramids and Egyptian monuments. Others created sophisticated democratic institutions like the Iroquois Confederacy and various African kingdoms. Still others developed extensive trade networks and commercial systems like the Phoenician, Mediterranean network and the Transaeran trade routes. Despite vast distances and geographic barriers, human societies developed surprisingly extensive networks of contact and exchange. Trade routes connected communities across continents, carrying not just goods, but ideas, technologies, and cultural innovations. The Silk Road linked Asia and Europe. Trans-Pacific contacts connected Polynesia and the Americas, and trans-Saharan routes integrated North and Sub-Saharan Africa. These networks revealed that human societies were never truly isolated. Even before modern transportation, ideas and innovations could spread across vast distances through chains of cultural contact. The development of metallurgy, agricultural techniques, artistic styles, and social institutions often showed remarkably rapid diffusion across enormous geographic ranges. The genetic evidence supports this picture of connectivity despite thousands of years of geographic separation. Human populations maintained enough gene flow to prevent complete genetic divergence. The mixing of populations through trade, migration, and cultural contact created the complex genetic patterns we see in modern humans. Human societies that survived for thousands of years developed sophisticated environmental management practices that maintained ecological balance while supporting human populations. Indigenous fire management in Australia prevented catastrophic wildfires while maintaining grassland ecosystems. Polynesian communities created sustainable island agriculture that could support dense populations indefinitely. Native American societies managed vast forest ecosystems that supported both human communities and biodiversity. These traditional ecological practices demonstrate that humans could live sustainably even in challenging environments. The key was developing deep understanding of local ecological processes and creating social institutions that could maintain sustainable practices across multiple generations. Many traditional societies developed elaborate cultural mechanisms, religious beliefs, seasonal ceremonies, and social taboos that ensured environmental conservation. Thought the collapse of some societies, like the Easter Island civilization or the Maya city-states, provides cautionary tales about the consequences of environmental overexploitation. These failures weren't inevitable results of human settlement, but rather the products of specific social and environmental circumstances that overwhelmed traditional management systems. The geographic isolation of human populations during global expansion created extraordinary cultural diversity. Each region developed its own languages, art forms, religious systems, and social institutions adapted to local conditions and historical experiences. This diversity became a source of continuous innovation as different societies developed unique solutions to universal human challenges. The variety of human languages that emerged during global expansion represents one of our species' greatest achievements. Linguists estimate that humans developed thousands of distinct languages, each representing a unique way of understanding and describing the world. This linguistic diversity reflects the cognitive flexibility that enabled human adaptation to diverse environments. Artistic traditions similarly flourished in isolation, creating the remarkable diversity of human aesthetic expression. From Paleolithic cave paintings to Polynesian navigation charts, from African textile traditions to Native American storytelling, each society developed distinctive ways of expressing human creativity and preserving cultural knowledge. The patterns established during humanity's global expansion continue to influence modern world. The genetic diversity created by ancient migrations affects everything from medical research to agricultural development. The cultural traditions developed by isolated societies provide insights into human creativity and alternative ways of organizing social life. The environmental management practices of traditional societies offer models for sustainable development. Understanding the achievements of ancient human societies also provides perspective on modern global challenges. Our ancestors successfully adapted to climate change, developed sustainable resource management practices, and created resilient social institutions that survived for millennia. Their experiences offer both inspiration and practical guidance for addressing contemporary global challenges. The global expansion of humans created the foundation for all subsequent human development. The agricultural systems developed during settlement provided the food surpluses necessary for complex civilizations. The trade networks established during migration became the basis for global commerce. The cultural innovations developed in isolation became the raw materials for later cultural synthesis. Most importantly, the global expansion of humans established our species' fundamental capacity for adaptation and innovation. The challenges overcome during migration, from Arctic survival to oceanic navigation, demonstrated that human ingenuity could triumph over seemingly impossible obstacles. This confidence in human problem-solving ability became a defining characteristic of our species. The world that ancient migrants built wasn't a primitive precursor to modern civilization. It was a complex, diverse, and sophisticated global human community. The societies they created successfully managed resources, maintained social order, and fostered cultural development across thousands of years. Their achievements provide both a record of human potential and a guide for future development. The story of human global expansion reveals our species at its best: creative, courageous, and cooperative. The descendants of African migrants who crossed deserts, oceans, and ice sheets to populate the entire world had transformed the planet through human ingenuity and determination. They had laid the foundation for everything that would follow. Chapter 10: The Technology of Survival. The story of human migration cannot be told without understanding the revolutionary technologies that make global expansion possible. Every successful journey into unknown territory required innovations that would have seemed impossible to previous generations. From the first carefully crafted spear points to sophisticated navigation instruments, human technology evolved in response to the challenges of exploration and settlement. The earliest migrants carried with them a toolkit that represented hundreds of thousands of years of accumulated knowledge. Stone tools had evolved from simple choppers to sophisticated multi-component weapons and processing equipment. But it was the innovations developed during migration itself that truly transformed human capabilities. Each new environment demanded specific technological solutions that pushed the boundaries of what was possible with available materials. Archaeological evidence reveals that technological innovation accelerated dramatically during periods of migration. The pressure of survival in unfamiliar environments forced rapid experimentation and adaptation. Communities that could innovate quickly gained decisive advantages over those that couldn't adapt their technologies to new challenges. This technological arms race drove human ingenuity to new heights. One of the most significant technological breakthroughs that enabled global migration was the development of sophisticated projectile weapons. The invention of the spear thrower atlatl around 40,000 years ago revolutionized hunting and a few shrines, allowing humans to kill large prey from safe distances and defend themselves against formidable predators. This technology provided crucial advantages in environments populated by megapods that had never encountered human hunters. The spear thrower worked by extending the length of the throwing arm, dramatically increasing the velocity and range of spears. A skilled hunter could accurately target prey at distances of 50 to 100 meters, transforming hunting strategies and making it possible to exploit new food sources. The psychological impact was equally important. Communities armed with spear throwers could confidently venture into territories dominated by large predators. The development of the bow and arrow appearing independently in different regions around 20,000 to 30,000 years ago, represented another technological leap. Bows provided even greater accuracy and range than spear throwers, while arrows could be mass-produced and specialized for different types of prey. The bow's advantages were so significant that it rapidly spread to every human population, becoming one of the first truly global technologies. The conquest of the world's oceans required perhaps the most sophisticated technological achievements of the ancient world. Early watercraft evolved from simple rafts and dugout canoes to complex vessels capable of long-distance ocean voyages. Each maritime environment demanded specific adaptations: riverine craft, optimized for shallow water, and portability; coastal vessels designed for surf and tidal conditions, and ocean-going ships, capable of surviving storms in multi-week journeys. The development of the outrigger canoe in Southeast Asia represented a quantum leap in maritime technology. By adding lateral support floats, builders created vessels that combine stability with speed, making it possible to safely cross significant stretches of open ocean. The double-hulled sailing canoes developed by Polynesian builders took this concept even further, creating platforms capable of carrying entire communities along with livestock, supplies, and fresh water for extended voyages. Navigation technology evolved alongside vessel design. Early navigators developed techniques for reading ocean swells, interpreting cloud formations, and tracking celestial movements that allowed precise navigation across thousands of kilometers of open ocean. The stick charts used by Marshall Island navigators represented sophisticated, three-dimensional models of wave patterns and island positions, while Polynesian star compasses provided detailed information about seasonal navigation routes. The colonization of northern latitudes required revolutionary innovations in clothing, shelter, and heating technology. The development of tailored clothing using specialized tools like eyed needles represented a technological breakthrough that made Arctic survival possible. These weren't simple animal skin wrappings, but sophisticated multi-layer systems designed to maximize insulation while allowing freedom of movement. Archaeological evidence from sites like Doli Vistanis reveals the complexity of ice-age clothing technology. Humans developed techniques for processing different types of animal skins, creating waterproof outer layers and insulating inner garments. They learned to work with materials like mammoth fur, seal skin, and bird feathers, each providing specific advantages for different conditions and activities. Shelter technology evolved to meet the challenges of environments where traditional building materials were scarce. The mammoth bone houses found at sites like Misurich demonstrate remarkable engineering ingenuity. Substantial structures built entirely from the bones and tusks of extinct megapora, designed to withstand fierce Arctic winds while providing insulation for small communities. These shelters required careful planning and sophisticated understanding of structural engineering principles. Mastery of fire represented one of humanity's earliest and most important technological achievements. But the challenges of migration demanded increasingly sophisticated fire management techniques. Different environments required different approaches to fuel gathering, fire starting, and heat conservation. Arctic peoples developed techniques for burning animal fat and bone when wood was unavailable, while tropical populations learned to manage fires and humid conditions where traditional tinder wouldn't ignite. The development of portable fire-starting technology was crucial for mobile populations. Evidence suggests that early humans carried glowing embers in specially designed containers during long journeys, maintaining fire across vast distances. Later innovations included friction-based fire-starting tools like bow drills and fire pistons, which allowed reliable fire creation using locally available materials. Cooking technology evolved alongside fire management with different populations, developing specialized techniques for processing unfamiliar foods. The earth ovens used by Polynesian peoples allowed efficient cooking of root vegetables and preservation of meat during long voyages. Smoking and drying techniques, developed by northern peoples, enable long-term food storage, essential for surviving harsh winters or extended journeys. Each new environment encountered during human migration required innovations in food, procurement, processing, and preservation. The toolkit carried by migrating populations included specialized implements for different types of food processing, grinding stones for processing seeds and nuts, cutting tools for butchering large game, and scraping tools for preparing hides and processing fish. On the development of complex food processing techniques often made the difference between successful settlement and failure. Native American populations developed sophisticated techniques for processing toxic plants, like acorns and cassava, removing dangerous compounds through lengthy preparation processes. Arctic peoples perfected methods for preserving fish and meat that could sustain communities through months when fresh food was unavailable. Fermentation technology, developed independently by multiple populations, provided crucial advantages in food preservation and nutrition. The fermented fish sources of Southeast Asia, the fermented dairy products of pastoral peoples, and the fermented plant foods of various agricultural societies all demonstrated how biological processes could be harnessed to improve food security and nutritional value. Long-distance migration required sophisticated systems for storing and transmitting information across generations. Different populations developed various approaches to preserving crucial knowledge about navigation routes, seasonal patterns, resource locations, and survival techniques. These information storage systems were often embedded in cultural practices that ensured reliable transmission across multiple generations. Oral traditions developed into highly sophisticated systems for preserving complex information. Polynesian navigation charts contain detailed information about star patterns, island locations, and ocean conditions, while Australian Aboriginal songlines preserved geographical information across vast territories. These oral traditions use repetition, rhythm, and narrative structure to ensure accurate transmission of vital survival information. Physical information storage systems included everything from the carved navigation charts of Pacific Islanders to the winter counts of Plains Indian peoples. These systems allowed communities to accumulate knowledge over multiple generations, building databases of environmental information that would prove crucial for successful adaptation to new territories. As human populations spread across vast territories, the need for tool standardization and resource exchange became increasingly important. Successful communities developed techniques for creating tools that met specific performance standards, ensuring that essential equipment could be relied upon during critical situations. This standardization also facilitated trade between different communities, allowing access to superior materials and specialized knowledge. The development of trade networks for tool-quality materials represents one of the earliest forms of economic specialization. Obsidian from volcanic sources was traded across thousands of kilometers because of its superior cutting properties. High-quality flint, certain types of wood, and specific minerals were exchanged between communities that specialized in processing these materials into essential tools. These trade networks also facilitated the rapid spread of technological innovations. New tool designs, improved processing techniques, and innovative material applications could spread across vast distances through established exchange relationships. This technological diffusion accelerated human adaptation to new environments and ensured that successful innovations weren't lost when individual communities failed. The true power of human technology lay not in individual innovations, but in the compound effect of multiple technologies working together. A successful Arctic expedition required not just warm clothing, but also reliable fire-starting equipment, effective hunting weapons, portable shelter, food preservation techniques, and navigation tools. The failure of any single component could doom an entire venture. This technological integration required sophisticated planning and resource management. Communities had to maintain expertise in multiple technological domains while ensuring that all necessary tools and materials were available when needed. The complexity of these technological systems explains why successful migration often required large communities with diverse skill sets rather than small groups of specialists. The cumulative effect of technological innovation over thousands of years created an enormous advantage for later migrants compared to earlier ones. By the time humans were colonizing the Pacific Islands or crossing to the Americas, they possessed technological capabilities that would have seemed magical to their ancestors. This technological acceleration continued throughout human history, with each generation building on the innovations of previous ones. The relationship between environment and technology was dynamic, with each new challenge driving further innovation. While successful adaptations opened new possibilities for expansion, Arctic technologies enabled survival in previously uninhabitable regions, while maritime innovations made island colonization possible. Each successful adaptation created opportunities for further exploration and settlement. Environmental feedback also drove specialization and regional technological traditions. Communities that became expert at desert survival developed different tool traditions than those specializing in maritime environments. This diversification created a global network of technological knowledge that could be drawn upon as needed for new challenges. The technological achievements of ancient human migrants laid the foundation for all subsequent human development. The problem-solving approaches, material science knowledge, and engineering principles developed during global expansion became the basis for later technological revolutions. Understanding these ancient innovations provides insights into human creativity and the transformation and fundamental principles that continue to drive technological progress today. Chapter 11. The Language of Exploration. As humans spread across the globe, something remarkable happened to their most fundamental tool of communication: language. What began as a shared system of communication in Africa gradually diversified into thousands of distinct languages, each adapted to specific environments, cultures, and survival needs. This linguistic explosion represents one of the most extraordinary achievements of human migration, creating a global tapestry of communication systems that reflects the full diversity of human experience. The process of linguistic diversification followed predictable patterns tied to migration, routes, and geographical barriers. When populations split and lost regular contact, their languages began to diverge through natural processes of linguistic change. Mountains, deserts, and oceans created linguistic boundaries that persisted for thousands of years. The result was a global map of language families that closely mirrors the routes taken by ancient migrants. Linguists estimate that humans developed between 6,000 and 7,000 distinct languages during the period of global expansion. Each language represented not just a communication system, but a unique way of understanding and categorizing the world. The diversity of linguistic solutions to universal communicative challenges demonstrates the remarkable flexibility of human cognitive abilities and the creative potential of cultural evolution. Different environments created distinct vocabulary needs that shaped the development of specialized linguistic systems. Arctic peoples developed elaborate vocabularies for describing different types of snow and ice conditions, not because they had more words for snow than other languages, but because precise communication about frozen conditions was essential for survival. These weren't merely descriptive terms, but functional vocabularies that could convey life or death information about travel conditions and hunting opportunities. Dawn maritime cultures developed equally sophisticated vocabularies for oceanic conditions. Polynesian languages contained hundreds of terms for describing ocean swells, wind patterns, and weather conditions that were invisible to land-based observers. These vocabularies weren't just descriptive, they were functional navigation tools that allowed precise communication about complex, oceanic phenomena essential for long-distance sailing. The development of these specialized vocabularies reveals how language adaptation paralleled technological and cultural adaptation to new environments. Communities that successfully colonized challenging environments developed not just the tools and techniques necessary for survival, but also the linguistic systems needed to communicate effectively about environmental conditions and survival strategies. Different environments also influenced the grammatical structures that languages developed for expressing spatial and temporal relationships. Languages spoken by nomadic peoples developed complex systems for expressing direction, distance, and movement, while sedentary agricultural communities elaborated systems for expressing seasonal cycles and agricultural timing. These grammatical differences weren't arbitrary, they reflected the cognitive demands of different survival strategies. Desert peoples developed linguistic systems that could precisely encode information about water sources, travel routes, and territorial boundaries. These languages often included obligatory grammatical markers that specified the reliability of information, the source of knowledge, and the temporal validity of statements about environmental conditions. Such precision was essential when sharing information that could determine survival in harsh environments. Mountain peoples developed linguistic systems adapted to complex three-dimensional, where altitude, slope, and aspect could dramatically affect weather conditions and travel routes. These languages often included sophisticated systems for expressing vertical relationships and topographical features that would be unnecessary in flat terrain, but essential for survival in mountainous regions. Dot language served as the primary vehicle for transmitting essential survival knowledge across generations. Different communities developed various linguistic strategies for ensuring that crucial information about navigation, seasonal patterns, resource locations, and survival techniques would be preserved and accurately transmitted to future generations. Oral traditions evolved into highly sophisticated information storage systems that used rhythm, repetition, and narrative structure to ensure accurate transmission of complex information. Epic poems, ceremonial chants, and ritual narratives served as databases of environmental knowledge that could be accessed when needed. These systems were often more reliable than written records because they included built-in error correction mechanisms and required active community participation to maintain. While linguistic techniques used for knowledge preservation varied widely between cultures, but shared common features that enhanced memorability and accuracy. Sacred narratives often embedded practical information within compelling stories that would be remembered and retold. Genealogical recitations preserved information about territorial rights and resource. Ceremonial languages maintained precise technical vocabularies that might otherwise be lost on as human communities adapted to diverse environments. Their languages developed different metaphorical systems for understanding abstract concepts. These metaphorical frameworks weren't merely poetic devices, they represented fundamental cognitive tools that shaped how communities understood relationships, causation, and social organization. Desert cultures often develop metaphorical systems based on water scarcity and conservation, while forest peoples created metaphors derived from growth cycles and ecological relationships. Maritime cultures used oceanic metaphors for understanding social and relationships and temporal processes. These metaphorical systems provided cognitive frameworks that helped communities understand complex abstract relationships by relating them to familiar environmental phenomena. The diversity of metaphorical systems created different ways of thinking about universal human experiences like time, space, social relationships, and causation. This cognitive diversity became a source of creative potential that enhanced human problem-solving abilities and cultural innovation. Communities with different metaphorical frameworks could offer unique perspectives on shared challenges. As human communities spread across vast distances, the need for communication between different language groups became increasingly important. This need drove the development of trade languages, pidgins, and other simplified communication systems that allowed basic interaction between speakers of mutually unintelligible languages. These contact languages often developed along major trade routes and geographical bottlenecks where different populations regularly encountered each other. River confluences, mountain passes, and coastal harbors became centers of linguistic innovation were simplified. Communication systems evolved to meet the needs of multilingual interaction. The development of trade languages reveals the human capacity for rapid linguistic innovation when communicative needs arise. These systems could develop within a single generation when circumstances required communication between different language groups. The speed of this linguistic adaptation paralleled the rapid technological and cultural adaptations that characterize successful human migration. Many communities develop specialized sacred languages that serve different functions from everyday communication. These ritual languages often preserved archaic forms that maintain connections to ancestral communities while serving specialized functions in ceremonial contexts. Sacred languages provided ways of maintaining cultural continuity across vast distances and long periods of separation. The development of sacred languages also reflected the human need to create linguistic systems that could express concepts and experiences that transcended everyday communication needs. These languages often included specialized vocabularies for discussing spiritual concepts, ancestral knowledge, and cosmic relationships that require different communicative strategies than practical survival information. Religious and ceremonial languages served as repositories for cultural knowledge that might otherwise be lost during periods of environmental stress or social disruption. These specialized linguistic systems provided backup storage for essential cultural information and maintained connections to ancestral wisdom that could be crucial for long-term community survival. The development of writing systems in various parts of the world represented a revolutionary breakthrough in human information storage and transmission capabilities. Different communities developed writing systems adapted to their specific linguistic and cultural needs, creating diverse approaches to encoding language in permanent visual form. Some writing systems evolved from pictographic representations of concrete objects, while others developed from abstract symbolic systems. The diversity of writing system types reflects different cognitive approaches to the relationship between spoken and visual representation. Each system represented a unique solution to the challenge of preserving information across time and space. The impact of writing systems on human migration and settlement was profound. Written records allowed communities to accumulate information across multiple generations, building detailed knowledge bases about environmental conditions, resource locations, and survival strategies. This information accumulation capability provided significant advantages for communities that developed effective writing systems. Modern linguistic analysis provides powerful tools for reconstructing ancient migration patterns and cultural relationships. By comparing the vocabularies, grammatical structures, and sound systems of related languages, linguists can trace the historical relationships between different communities and estimate the timing of population splits. Linguistic evidence often complements archaeological and genetic data in revealing the details of human migration patterns. Language families reflect ancient population relationships, while borrowed words reveal historical contact between different communities. The distribution of linguistic features across geographical space provides insights into the routes taken by ancient migrants and the timing of their movements. The reconstruction of proto-languages, the ancestral languages from which modern language families descended, provides windows into the cultures and environments of ancient communities. The vocabularies of reconstructed proto-languages reveal information about the technologies, social organizations, and environmental adaptations of populations that lived thousands of years ago. Communities that maintain contact with multiple language groups often developed multilingual capabilities that provided significant cognitive and cultural advantages. Multilingual individuals could serve as cultural bridges, facilitating trade, alliance formation, and information exchange between different communities. These linguistic abilities were often highly valued and created specialized social roles within communities. The cognitive benefits of multilingualism extended beyond simple communication. Advantages: individuals who spoke multiple languages often developed enhanced cognitive flexibility, improved problem-solving abilities, and greater cultural awareness. These cognitive advantages could provide significant benefits for communities facing the challenges of migration and adaptation to new environments. About the preservation of multilingual capabilities within communities required. Deliberate cultural strategies have valued linguistic diversity and maintained contact with multiple language groups. Communities that successfully maintained these capabilities often became centers of cultural innovation and technological exchange that influenced much larger geographical regions. The linguistic diversity created during human global expansion continues to influence modern human societies in profound ways. Different languages preserve unique ways of understanding and categorizing the world that provide insights into human cognitive potential and cultural creativity. This linguistic heritage represents one of humanity's greatest intellectual achievements. About the ongoing loss of linguistic diversity through language extinction represents the loss of unique cognitive and cultural resources that took thousands of years to develop. Each language that disappears takes with it distinctive ways of understanding the world and solving human problems. The preservation of linguistic diversity remains one of the most important challenges facing modern human societies. Understanding the linguistic achievements of ancient human migrants provides insights into the fundamental human capacity for communication and cultural adaptation. The development of thousands of distinct languages during global expansion demonstrates the remarkable creativity and flexibility of human cognitive abilities when faced with diverse environmental and social challenges. Chapter 12. The Social Architecture of Survival. The success of human migration depended not just on individual courage and skill, but on the development of social systems that could maintain group cohesion under extreme stress. Every successful journey into unknown territory required communities that could make collective decisions, resolve conflicts, share resources fairly, and maintain morale during long periods of uncertainty and hardship. The social innovations developed during global expansion became the foundation for all subsequent human civilizations. Archaeological evidence reveals that successful migrant communities developed remarkably sophisticated social organizations adapted to the specific challenges of exploration and settlement. These weren't random collections of individuals, but carefully structured groups with defined roles, decision-making procedures, and conflict resolution mechanisms. The complexity of these social systems often determined whether communities survived or perished in challenging new environments. thought the scale of social organization varied depending on the challenges faced and resources available. Arctic communities required different organizational structures than desert peoples, while maritime explorers needed social systems adapted to the unique challenges of long-distance ocean voyaging. Each environment fostered specific social innovations that would maximize survival chances under local conditions. Migration communities required leadership systems that could function effectively under total uncertainty and stress. Traditional hierarchical systems often proved inadequate for the novel challenges of exploration, driving the development of more flexible and adaptive leadership structures. Successful communities often developed multiple leadership roles adapted to different types of decisions and environmental challenges. The most effective migration leaders weren't necessarily those with the highest status in settled communities, but individuals with specific skills essential for exploration and survival. Navigation expertise, environmental knowledge, and crisis management abilities became more important than traditional markers of authority. This created opportunities for individuals to achieve leadership roles based on demonstrated competence rather than inherited status. Decision-making processes in migration communities required balancing the need for quick action during emergencies with the importance of group consensus for major directional choices. Communities develop various mechanisms for achieving this balance, including rotating leadership roles, specialized decision-making councils, and emergency protocols that could be activated during crisis situations. The challenges of migration and settlement in new environments required economic systems that could function under conditions of scarcity and uncertainty. Traditional exchange mechanisms often proved inadequate for the novel challenges of exploration, driving communities to develop innovative approaches to resource allocation and economic organization. Successful migration communities typically develop sophisticated sharing systems that ensured equitable distribution of essential resources while maintaining incentives for individual contribution to group welfare. These systems often included mechanisms for storing and redistributing resources during periods of abundance, insurance systems that protected individuals against loss or injury, and reciprocal exchange relationships that maintain social cohesion. Development of specialized economic roles within migration communities reflected the complex skill sets required for successful exploration and settlement. Communities needed individuals with expertise in navigation, environmental assessment, resource procurement, tool manufacture, and social coordination. The economic systems that emerged needed to support this specialization while maintaining group cohesion and shared purpose. The kinship systems developed by migration communities played crucial roles in maintaining social cohesion during long journeys in establishing legitimate authority in new territories. These systems often underwent significant modifications as communities adapted to the challenges of exploration and the need to integrate new members encountered during migration. Many successful migration communities developed fictive kinship systems that could rapidly incorporate unrelated individuals into existing social networks. These adoption mechanisms were essential for maintaining viable breeding populations during long journeys and for integrating knowledge from local populations encountered during settlement. The flexibility of these kinship systems often determined community survival prospects. Marriage systems within migration. Communities required balancing the need to maintain genetic diversity with the practical constraints of small population sizes and uncertain futures. Communities developed various strategies for managing these challenges, including complex alliance systems with other communities, delayed marriage practices that maximize reproductive choices, and flexible marriage arrangements that could adapt to changing circumstances. The stress of migration and the vision and the current challenges of establishing communities in new environments created numerous opportunities for internal conflict that could destroy group cohesion and threaten survival. Successful communities developed sophisticated conflict resolution mechanisms that could address disputes quickly and fairly while maintaining group unity and preventing the escalation of minor disagreements into community-threatening conflicts. These conflict resolution systems often included multiple stages of intervention, from informal mediation by respected community members to formal judgment procedures for serious offenses. The most effective systems emphasize restoration of social harmony rather than punishment, recognizing that community survival depended on maintaining cooperation among all members. The development of justice systems within migration communities required balancing individual rights with collective survival needs. Communities needed to maintain high standards of behavior essential for group survival, while providing fair treatment for individuals who violated community norms. The solutions developed often became models for larger social organizations in settled communities. Migration communities faced the crucial challenge of transmitting essential knowledge and skills to younger generations while adapting to rapidly changing environmental and social conditions. Traditional education systems often proved inadequate for the novel challenges of exploration, requiring communities to develop innovative approaches to knowledge preservation and skill transmission. Successful communities developed educational systems that combined practical skill training with cultural knowledge preservation, ensuring that essential survival skills would be maintained while preserving cultural identity and social cohesion. These systems often included formal initiation procedures, specialized mentorship relationships, and community-wide knowledge-sharing practices. The content of education systems in migration communities reflected the specific survival challenges faced by each group. Arctic peoples developed elaborate educational systems for transmitting knowledge about ice conditions and Arctic survival techniques. Maritime communities created complex training programs for navigation and seamanship skills. Desert peoples developed educational traditions focused on water location and desert survival techniques. Religious and ceremonial practices played essential roles in maintaining community cohesion and psychological resilience during the stress of migration and settlement in challenging environments. These practices provided frameworks for understanding and coping with uncertainty, mechanisms for reinforcing social bonds, and systems for preserving and transmitting cultural knowledge. Successful migration communities often develop portable ceremonial systems that could be maintained during long journeys and adapted to new environments. These systems included simplified ritual equipment, flexible ceremonial procedures, and adaptable mythological frameworks that could incorporate new experiences and environmental challenges. Thought the psychological functions of ceremonial practices were particularly important during migration, providing communities with sources of meaning and identity that transcended immediate survival challenges. These practices helped maintain morale during difficult periods, provided frameworks for making sense of new experiences, and created opportunities for community bonding and social reinforcement. Migration communities often required significant modifications of traditional gender roles to meet the survival challenges of exploration and settlement in new environments. The demands of migration frequently required individuals to perform tasks outside their current traditional gender assignments, leading to more flexible and pragmatic approaches to social organization. Successful communities often develop complementary gender role systems that maximize the utilization of all available human resources while maintaining social stability. These systems typically included mechanisms for individuals to assume non-traditional roles when circumstances required, while preserving core cultural values and social structures. The evolution of gender role systems in migration communities often reflected the specific survival challenges faced by each group. Communities facing primarily hunting challenges might develop different gender role adaptations than those relying primarily on gathering or maritime resources. The flexibility of these systems often determined community survival prospects in challenging environments. Migration communities frequently encountered other human groups during their journeys, requiring sophisticated diplomatic skills and alliance formation capabilities. The success of these encounters often determined whether communities could access essential resources, gain valuable local knowledge, or establish peaceful relationships that would facilitate long-term settlement. Successful communities developed various strategies for managing intergroup relations, including gift exchange systems, intermarriage arrangements, and formal alliance agreements. These diplomatic systems require careful balance between maintaining community identity and interests while building productive relationships with other groups. The development of intergroup communication and negotiation skills was particularly important for communities settling in regions already occupied by other human populations. These skills often determined whether settlement attempts would succeed through peaceful cooperation or fail through conflict and competition for resources. Migration communities served as laboratories for social innovation, developing new approaches to organization and cooperation that were later adopted by larger and more stable societies. The pressures of survival in challenging environments forced rapid experimentation with social forms and the abandonment of traditional practices that proved ineffective under new conditions. The social innovations developed by migration communities often included more egalitarian decision-making procedures, more flexible kinship systems, and more efficient resource allocation mechanisms than those found in settled societies. These innovations were driven by the practical necessities of survival rather than abstract social theories, but often prove superior to traditional systems. The successful social innovations developed during migration often influence the development of later civilizations, providing models for social organization that can handle complex challenges and diverse populations. The social architecture developed during humanity's global expansion became the foundation for the complex societies that would emerge as populations settled and grew in their new territories. The social systems developed during human migration created templates for social organization that continue to influence modern societies. The emphasis on merit-based leadership, flexible social roles, and cooperative resource management developed during migration became fundamental principles of democratic and egalitarian social systems. Understanding the social achievements of migration communities provides insights into the fundamental human capacity for social innovation and cooperation under stress. These achievements demonstrate that humans can develop sophisticated social organizations even under the most challenging circumstances, and that social innovation often emerges from practical necessities rather than abstract planning. The social architecture developed during humanity's global expansion represents one of our species' greatest achievements, demonstrating the remarkable human capacity for creating cooperative systems that can function effectively under extreme conditions. These innovations continue to provide models for addressing modern social challenges and building resilient communities capable of adapting to changing circumstances. Today, when you look in the mirror, you're seeing the face of an explorer. Every human alive carries within their cells the genetic legacy of those brave pioneers who first ventured beyond Africa's borders 70,000 years ago. Your mitochondrial DNA traces an unbroken line back to one of perhaps just a few hundred women who participated in humanity's great exodus. Your Y chromosome, if you're male, connects you directly to the men who crossed treacherous waters, survived ice ages, and colonized continents. These genetic markers aren't just abstract scientific data, they're molecular memories of humanity's greatest adventure. When scientists analyze your DNA, they can trace the precise route your ancestors took as they spread across the globe. They can tell you whether your lineage passed through the Arabian Peninsula or followed the southern coast of Asia. They can reveal when your ancestors reached Europe, crossed to the Americas, or settled the Pacific Islands. You are quite literally a walking museum of human migration history. The genetic diversity we see in modern human populations is a direct result of the founder effects, bottlenecks, and adaptations that occurred during global expansion. The variations in skin color, facial features, and body proportions that characterize different populations all reflect adaptations to specific environments encountered during migration. These aren't superficial differences, they're testaments to human adaptability and the diverse challenges our ancestors overcame. The abilities that enabled human global expansion haven't disappeared. They've been passed down through cultural transmission and remain embedded in human nature. The navigation skills that allowed Polynesian voyagers to cross vast Pacific expanses live on top in our spatial reasoning abilities. The environmental awareness that enabled Arctic peoples to survive in harsh conditions persists in our capacity to read natural signs and adapt to new situations. Modern humans retain the fundamental cognitive abilities that made global expansion possible: the capacity for long-term planning, the ability to cooperate in large groups, the flexibility to adapt cultural practices to new environments, and the drive to explore beyond familiar territories. These aren't ancient relics. They're active capabilities that continue to drive human achievement today. The problem-solving approaches developed during migration remain relevant for modern challenges. The ability to rapidly assess new environments, identify available resources, and develop innovative solutions using limited materials represents exactly the kind of thinking needed to address contemporary global challenges like climate change, resource depletion, and social inequality. The patterns established during humanity's ancient expansion continue to influence modern migration. Economic opportunities, environmental pressures, and social conflicts drive millions of people to leave familiar territories and seek better lives elsewhere, following routes and motivations remarkably similar to those of their ancient ancestors. The refugee camps of today echo the temporary settlements established by ancient migrants as they move between territories. Modern transportation technology has compressed the timescales and distances involved in migration, but the fundamental human experiences remain unchanged. Modern migrants face the same challenges of cultural adaptation, language acquisition, and community building that confronted their ancient predecessors. The social innovations developed during global expansion, flexible kinship systems, resource-sharing mechanisms, and conflict resolution procedures remain relevant for managing the challenges of modern displacement and resettlement. The global connectivity enabled by modern technology creates opportunities for maintaining cultural connections across vast distances that would have been impossible for ancient migrants. Yet the basic human needs for community identity and belonging that drove ancient social innovations remain unchanged in modern migration context. As humanity prepares for the next great expansion into space, the lessons learned during global terrestrial expansion become increasingly relevant. The challenges of establishing sustainable communities in hostile environments, maintaining social cohesion during long journeys, and developing technologies for survival in extreme conditions directly parallel the challenges faced by ancient migrants. The psychological and social factors that determine success or failure for ancient migration communities will be equally important for space colonization efforts. The leadership systems, decision-making procedures, and conflict resolution mechanisms developed during terrestrial expansion provide tested models for organizing space exploration, missions, and establishing extraterrestrial settlements. The technological innovation cycles that drove ancient migration, the development of specialized tools, the integration of multiple technologies, and the adaptation to new environmental challenges offer insights into the kind of technological development needed for successful space expansion. The compound effects of multiple innovations that enabled ancient oceanic voyaging provide PROST models for the integrated life support systems needed for space exploration. The human story of exploration and expansion didn't end with the completion of global terrestrial colonization. It simply entered a new phase. The same drives that pushed ancient humans beyond familiar territories continue to motivate modern exploration of ocean depths, polar regions, and extraterrestrial environments. The fundamental human characteristics that enable global expansion, curiosity about unknown territories, confidence in human problem-solving abilities, and willingness to take calculated risks for potential benefits, remain active forces in human maturity. But modern scientific exploration follows patterns established during ancient migration, systematic investigation of new environments, careful documentation of discoveries, development of specialized technologies for survival in challenging conditions, and gradual expansion of human presence into previously inaccessible territories. The space program, deep ocean exploration, and polar research all represent continuations of the exploration tradition that began 70,000 years ago in Africa. The social innovations that enabled ancient migration continued to evolve in response to modern challenges. International cooperation mechanisms, global communication networks, and collaborative scientific research programs all reflect developments of the alliance-building and information-sharing systems that enabled successful ancient migration. Perhaps the most important lesson from humanity's ancient expansion is the fundamental unity underlying apparent human diversity. Despite thousands of years of geographic separation and cultural evolution, all humans share the same basic cognitive abilities, social needs, and creative potential that enable global expansion. The surface differences between human populations pale in comparison to the shared heritage of exploration, adaptation, and innovation that defines our species. Understanding the achievements of ancient human migrants provides perspective on human potential and resilience. Our ancestors successfully adapted to every environment Earth could offer, from Arctic tundra to tropical rainforests, from high mountain plateaus to isolated islands. They developed sustainable societies, sophisticated technologies, and complex cultural traditions that persisted for thousands of years. These achievements demonstrate that humans can overcome seemingly impossible challenges through cooperation, innovation, and persistence. The story of human global expansion is ultimately a story about what becomes possible when human creativity and determination are fully engaged. It's a reminder that our species' greatest achievements have always emerged from the willingness to venture into the unknown, confident in our ability to adapt and thrive in whatever circumstances we encounter. As we face the challenges of the 21st century and beyond, we can draw inspiration from the remarkable journey that brought us to where we are today. We are the descendants of the most successful explorers in Earth's history. The same capabilities that enabled them to conquer a planet remain available to help us build a Standing at the end of this epic journey, we can finally answer the question we posed at the beginning. How did humans spread across the Earth? The answer is both simpler and more complex than we might have imagined. The simple answer is that humans spread through a combination of curiosity, necessity, and extraordinary courage. Climate changes opened corridors and closed others, pushing our ancestors into new territories. Population pressure and resource competition motivated exploration, but ultimately it was human ingenuity, our species' unique ability to solve problems, adapt to new environments, and cooperate in the face of overwhelming challenges that made global expansion possible. The complex answer reveals a story of multiple migrations, false starts, environmental catastrophes, genetic bottlenecks, technological innovations, and cultural achievements that span 70,000 years. It's a story written in DNA, stone tools, and ancient climate records. It's a tale of Neanderthal encounters, volcanic winters, oceanic crossings, and the patient accumulation of knowledge across hundreds of generations. But perhaps most remarkably, this ancient story continues today. The same drives that pushed our ancestors out of Africa, curiosity about what lies beyond the horizon, the search for new opportunities, the desire to build better lives for their children, continue to motivate human exploration. We see it in the millions of people who migrate to new countries each year seeking opportunity and escape from conflict. We see it in the scientists exploring the deepest oceans and the engineers planning missions to Mars. The techniques our ancestors developed: careful planning, technological innovation, social cooperation, and environmental adaptation remain the keys to successful exploration. The challenges they overcame, dangerous journeys, hostile environments, resource limitations, and uncertain outcomes, mirror the challenges we face as we contemplate becoming a multi-planetary species. The story of how humans spread across Earth is ultimately a story about who we are as a species. We are the descendants of the most successful explorers in the history of life on Earth. We carry in our genes and our cultures the accumulated wisdom of pioneers who conquered every parent our planet could offer. As we face modern global challenges, climate change, resource depletion, social inequality, we can draw inspiration from our ancestors' achievements. They proved that human ingenuity and cooperation can overcome seemingly impossible obstacles. They demonstrated that our species thrives not by avoiding challenges, but by embracing them. The journey that began 70,000 years ago, with a small group crossing the Red Sea, continues today. Reaching toward the stars, we still explorers, still pioneers, still driven by the same curiosity and courage that carried our ancestors to every corner of the earth. The greatest journey in human history isn't over, it's just beginning. If you have made it this far, thank you for listening. Thank you for walking that ancient shore with me, for crossing oceans and ice fields, and generations of courage that brought your own ancestors to the place where you sit right now. If you would like to hear more stories like this, I would be honored to have you subscribe. It means more than you know to know that someone out there is listening. And as always, be gentle with yourself tonight. Rest well. Let the weight of the day slip away like water over stone. You have done enough. You have been enough. And there will always be another story waiting for you when you return. Good night.